I hope your GCSEs are going well. Yeah. So just as a quick intro, I'm sure a couple of people will join a bit further on. But yeah, my name is Daniel. I'm a GCSE and A-level maths tutor, and I run classes every week. So you guys have got paper 3 coming up in a couple of days. So what we're going to do is we're just going to go over a couple of past paper questions that I've picked out. And yeah, that's pretty much it. That's pretty much how the classes are run. So yeah, I'm going to share my screen now. And yeah, we'll make a start. So the way the questions are going, the way the lesson's going to go is I will give you a chance to try the question on your own. So depending on how many marks there are, determines how many minutes I'll give you. So the first one is this one. It's 2 marks. So I'll give you 2 minutes to try it. See how you get on, and then we'll go through it together. Now, while I'm explaining anything, if you have any questions, you need any help, you can just drop me a message in the chat as well. Cool. So yeah, that's the first one. See how you got on with that, and we'll go through it together. So this is proven algebraically some sort of expression here. How do we find proof? So I want you guys to just put your message in the chat. Put a 0 if you find these very difficult, very challenging, and put a 10 if you find these super, super easy. Cool, cool. You can see a 4. Fair enough. Fair enough. Okay. We'll just see how you get on with it. We'll drop it very, very shortly. Okay. You can see a 4 and a 6 so far. Cool. Good afternoon to anybody that just joined a few moments ago. We're just going over a couple of past paper questions today. So here's the first one that we're doing. So I'm going to give you guys about a minute more, and then we're going to go through it together. Okay, okay. So if you have an answer, just put yes in the chat, just so I know you guys have an answer. If you found it a bit, if you got a bit stuck, just let me know. But we're gonna go for it now. So it's only 2 marks, so apparently it's not too bad. Anyways, let's see. So it says n is an integer. Prove algebraically that the sum of 1/2 n plus 1 and 1/2 n plus 1 n plus 2 is always a square number. So whenever I'm dealing with algebraic proof, right? Well, I have these two expressions here, and we need to prove apparently it's always a square number, right? Now, this here is very important because we need to know what algebraically a square number is. And that's just going to be something, right? That is all squared. Yeah. So what we should do is, well, sum these. Well, that means just add them. Add them. You do the algebra, manipulate it, and we should hope to get at the end of it something that can be squared. Does that make sense? I want all you guys to do drop me a message in the chat just to say yes or no, just so that they're all okay with that. Is that clear? Yeah, good stuff. Good stuff. Okay, so then we've got this here. Let's read it one more time. Prove algebraically that the sum of these two things here, well, that just tells me I need to just add them together, don't I? Yeah. So it'll be 1/2 n and then n plus 1, and then plus 1/2 n plus 1, and then n plus 2. So now what I would do in this case, well, I would just expand and simplify it, wouldn't I? So if I do this times this here, I've got 1/2 n times n. This will give me 1/2 n squared. And then I've got 1/2n times 1. This is just plus a half n. Yeah? And then plus, and then this one here, what I would do is I would work out the two brackets first and then bring the half after, just to make it a bit clearer. Yeah? N times n is n squared. And then n times 2 is 2n. And then 1 times n is n. And then 1 times 2 is a 2, isn't it? So that's just a plus 2. Let me just move this a bit more. Like this. And then tidying up a little bit more, I have a half n squared plus 1/2 n plus a half. And then this becomes n squared plus 3n plus 2. And then now what I'm going to do is I'm just going to tidy up, aren't I? Yeah? I'm going to expand this bracket and then tidy up. So I have 1/2 n squared plus 1/2 n plus a half n squared plus a half times 3 is 3/2, so 3/2n, and then plus a half times 2 is just half of 2, which is 1. Yeah? So we get here. Now, remember what our aim is. We need to get a square number. So we know that we need something squared, something algebraic with a square in it. Yeah? So tidying this up now, we look at the n squared terms. I've got a half n squared here. I've got another half n squared here, right? What I'm going to do is I'm going to add these together, right? Now, can somebody tell me in the chat, when I do a half n squared plus another half n squared, what does that give me? Can somebody tell me in the chat? I'll give a couple of seconds. Exactly. Thank you very much, Ashera. It's n squared, isn't it? Because it's just 1/2 of something plus another half of that same thing. Two halves together make one whole. So this is just going to be n squared here. And then plus, well, we've got 1/2 of n, and then we've got 3 more halves. 1/2 plus 3 halves are 4 halves. Half of 4 is 2. So this must be 2n. And then we've got plus 1. So we're here. Let me know in the chat, guys. How many of us got to this point? Anybody get here? N squared plus 2n plus 1? Okay, no problem if you didn't. So remember, you get to this point here. Now, it says we need to check this is always a square number. And we know that a square number is just some sort of expression that can be squared, that has a square in it. So I'm here, and I need to somehow write this with a square somehow, right? Well, if I have a bracket like this, right, that means it must be factorized. Now, what type of expression do we call this, guys? Can somebody tell me in the chat, please? What type of expression do we call something like this? Begins with a Q. Exactly. Thank you very much, Ashira. To me, it's a quadratic. This is a quadratic. What does that mean, though? Well, we need to factorize a quadratic, and we know how we do that. We do that in a very specific way. N squared plus 2n plus 1, right? We look at this last number here. This is, we're going to put factors here. We look at this middle number here. This is going to be sum, yeah? Or add, whatever you want to use. What you're doing is you're looking for 2 factors of that last number. Notice how I put the plus there as well, because that plus is also part of the 1. Yeah, always bear that in mind. Yeah, we're looking for 2 factors of 1, which also add to make 2. And that's just clearly 1 and 1. So therefore, when we factorize this, we're going to get n here. We're going to get n here. Remember, you get 2 brackets and you put n and n because it's n squared. And then you're just going to put these 2 numbers in that you found. They're both positive, so it'll be plus 1, plus 1. Now, this here is the same bracket twice, right? The same thing twice. Well, we know that, for example, x times x is x squared. We've got n plus 1 times another n plus 1. This is just n plus 1, all squared. And can you see, this is exactly what they wanted us to prove, right? We've now got to something with a square, which is n plus 1 all squared. So you could just say, therefore, and then, to be fair, in GCSE, I don't think you need to write this statement like you do with A-level, but it's always just good practice anyway. Therefore, and then you write the question without the prove that part, yeah? So you write, therefore, those 3 dots mean therefore, right? Oops, so 1 second. I was meant to copy this. This here. And all you're going to do here is say, therefore, the sum of 1/2 n plus 1 and n plus 1, put this here, and 1/2 n plus 1 n plus 2 is always a square number. Does that make sense, guys? Did anybody get this correct? Just let me know in the chat. And does anybody want me to go for any of that again, or is this all clear? Just want to make sure we're all okay with this just before I continue. And good afternoon to anybody that joined in the last couple of minutes. We're just going through different past paper questions for the hour. So this is the higher class. So we're going to go through a couple of higher tier questions and see how we get on. So yeah, I haven't seen any messages in the chat, so I'm assuming this is all okay. So let's continue. Okay, so we've got this one now. This is 5 marks. I'm going to give you guys 5 minutes to try it and see how you get on. So got this here. It's 5 marks. See how you get on with it. Having a look at this one though, guys, just having a look at it. What are our thoughts on it? Put a 0 if you're looking at it thinking, I'm very confused, don't know what to do whatsoever. And put a 10 if you think this type of question is super easy. What do we think? Okay, see a 7. Good stuff. Good stuff. Cool. So yeah, give you a few minutes and we'll go through it together. Is there anybody that hasn't made a start? Is anybody completely stuck or confused? Or are we all okay? If I don't see any messages, I'm going to assume that you're all getting on okay. Everybody's made a start. If you haven't and you're a bit stuck, please let me know. Maybe a minute more. Okay, okay. Has anybody got an answer? Has anybody got an answer? If so, please let me know in the chat. Or if you're still working through it, just let me know, just so I have an idea as to how everybody's getting on. And I'm going to go through it very shortly, but I'm just going to wait for anybody to drop me a message just so I can see how we're all getting on with it. Okay. Cool, cool, cool. So let's do this one. It says the area of triangle ADC is 56 meters squared. Work out the length of AB. So straight away, looking at this, right? We've got triangles here, we've got angles. Can somebody tell me what topic is this question referring to? What topic is this clearly? What do we think? Beginning with T. Exactly. Thank you very much, Ashera. It's clearly trigonometry for sure, right? So we say to ourselves, okay, if it's trigonometry, what do? We need to remember our formulas and our rules: cosine rule, sine rule, half AB sine C, blah, blah, blah. Yeah. Now let's look at information. They've told us that the area of this triangle ADC, the one on the bottom, this area is equal to 56. Yeah. Now we need to work out the length of AB, which is this one here, right? We're going to call this one. Let's call this X, for example. Okay, well, we know that the fact that they've given us some information about this triangle here means that we need to definitely use it, right? Now, for me, because the X is here on this top triangle, I know somehow I need to work this out. Now, looking at this triangle here, because remember, think about what you're trying to get to. I can see here that, well, I've got an angle here, and I've got an opposite side here, and I've also got this one. What rule is this looking like, do we think? What rule is this looking like in terms of trig? Exactly. Thank you very much, Tommy. It's the sine rule, right? So for sure, we could say, well, the sine rule states that that letter, that side x over the opposite angle, sine 48, right, is equal to that side A to C, which we do not know, over sine 118. So basically, for me, the key for me in this question is to figure out what A to C is, because once I can figure out what A to C is, I can just plug this back in into this sine rule formula and rearrange to get X. Does that make sense so far, guys? Is that all clear? Just want to make sure. I'm going to wait for anybody just to say yes or no, just so that this is clear and I can continue. Yeah, good stuff. All right. Now, the question is, how do we get AC? Yeah. Okay. That's not clear. Okay. Just to clarify that again. So this here is the sine rule. This is the sine rule here. Right? What I've done here is we'll say, because I've got this triangle here, right? And I'm looking for this side eventually, I can see, if we know our sine rule formula as well, we can see that this is clearly a case of it, because I've got an angle here, and if I do the opposite side here, I've got X. And then I have another angle here, and I have an opposite side. So these two, when you're dealing with the sine rule, you always draw an arrow between your angle and the opposite side, and that will tell you which side you use. So all I've done is just use this formula here. This should look familiar. A over sine A is equal to B over sine B over C over C equals C over sine C. Does this look familiar to anybody that was a bit confused? This is the sine rule. Yeah, good stuff. Good stuff. Cool. So all I've done is just apply that there. So now continuing, all we're going to do now is we're just going to say, well, we're going to try and figure out what A to C is. Yeah, so let me get that here. Like this here. And then this is A, this is C, this is 105 degrees, and this is 11. Yes. Now they told us that the area is 56. Area is 56. Now, whenever I'm dealing with trigonometry and they ask me about an area, what comes to mind straight away is the formula for an area of a triangle, which is half AB sine C, isn't it? Half AB sine C. And remember, when you're dealing with half AB sine C, it's always the angle, right? Yeah. And the two sides, either side of the angle. Yeah. So, well, we don't know one of the sides. However, though, due to the fact that we have the area, we can use the formula to rearrange. So, for example, if this was, for example, C, this was A, and this was B, and the area is 56, well, then that would mean that 56, because that's the area, is equal to 1/2, and then A is 11, and then B is, we don't know what B is, and the sine of 105. Yeah. And then if I want to tidy this up, well, I would have, I could just do 56 is equal to, for example, half of 11 is 5.5, B, and then sine of 105. Yeah. And then what you can do as well, because I want to get B on its own, right? I can work this out and I can work this out. So I can bring these two together, right? And I can just divide it. So for example, it'll be like this: 56 is equal to 5.5 sine 105, right? Because this is just a number times by b. And then I could just divide both sides by that to give me what b is. Put this here. 5.5 sine 105. Yeah, this is equal to b. So now I can put this into my calculator, see what it gets me. So this will just be 56 over 5.5 sine 105. And this is equal to b. And then let me just make sure my calculator is in the wrong degrees, the wrong units. Make sure your calculator is in degrees, but it will be anyway. Yeah, so if I plug this in now, this will give me 10.54099, blah, blah, blah. Did anybody get this far? Anybody get this far? Just want to make sure we're all okay with this so far. Is this okay so far, just before I continue? Yeah, good stuff, good stuff, good stuff. Now, continuing, we know what this value would be is 10.50499, blah, blah, blah. Okay, remember what the key to this question is, though. The key was figuring out what A to C is. Why was that the key? Because if I can figure out what A to C is, I can now plug that into this sine rule formula on the top here and then rearrange to get X, which is what we're actually looking for. Yeah. Now, we know what B is 10.50499, blah, blah, blah. A is 11. That angle C is 105. How can I calculate that side A to C? Is there anything else that I can use? Any other rules or methods or formulas in trigonometry? Exactly, exactly. Thank you very much, Ashira. It's the cosine rule. How do we know it's the cosine rule? Well, one thing is that, well, we know that we need to use the sine rule for the last part. So it's probably looking like the cosine rule. That's one thing. And the second thing as well is that you need to remember the structure of when you can apply the cosine rule. Yeah. So let me just show you something very, very quickly, just so we know. Where is that cosine rule? Right here. Yeah. Cosine rule size formula. The cosine rule can be used to work out missing sides and angles in a triangle. We've got this size formula here. A squared is equal to b squared plus c squared minus 2bc cos a. This version of the cosine rule is used to find a missing side if you know two sides and the angle between them. So if you have two sides and the angle between, you can then find the opposite side, right? And then we've got the other one, angles formula. That's when you're looking for an angle and you know all three sides. So I want you guys to tell me on a scale of 0 to 10, how well do we know this and the two different types of variations? I put 0 if you don't know this at all, and put a 10 if this is very, very clear and you knew it very, very well. Okay, okay, cool, cool. So maybe some of us maybe have not done it yet, which is understandable. But yeah, this is the rule. So just let me know if it makes sense while I'm doing it. But it's just as long as you know it once, it's very, very easy. Yeah. So let me just where is our lesson? 10th of June today. Okay. So now continuing here. Well, we've got this here, and we know that we have the exact same structure, right? Because we've got two sides and the angle in between. So we can figure out what A to C is here. So let's do that. So doing this here, this will be well, I'm gonna say, well, let's call this A to C, right? Well, according to the formula, A to C squared, right, is equal to the two sides, which is 11 squared, plus 10.54099 squared, minus two lots of B and C, or these two, the two sides, 11 and 10.54, blah, 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 cosine of the angle 105. So all I'm going to do now is I'm just going to put this into my calculator and then square root, and then that will give me the distance AC, and I'm pretty much done. Yeah. So let me do this here. Just make sure. Okay. Put this here 1 second, and then copy this here. So now, getting my calculator, I'm going to put this in. Now remember, when you're doing this, guys, when you're using your calculator, before you put it in, make sure you've written it all out correctly, and what you write is exactly what you put in your calculator. So now, can you see I've got this answer stored here? I'm not going to write the 10.5 blah 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 again because I have it there. So what I'm just going to say, well, 11 squared, right, plus answer squared minus 2 lots of 11 times answer cosine of 105. Cross, and then just make sure it's all okay. What's that? Make sure it's all okay. 11 squared, answer squared, perfect. 211 answer, perfect. Click equals. I get this here. So that tells me that AC squared is equal to that 292 point, sorry, where's my calculator? 1331, blah, blah, blah. Yeah? So therefore AC is equal to the square root of that. And remember, because I have it stored in my calculator, I can just do square root of answer. So I'm going to do square root of answer, and it gives me that. AC is equal to 17.091, blah, blah, blah. Now, why is this good? Because remember, we're looking for X, what we labeled X, A to B. Remember, at the very beginning, we knew that we needed to use the sine rule to answer this question, and the key was figuring out what A to C is. We now have this. So we can just plug this in here, rearrange, and that will give us X. Yeah? So we're going to do this now. Well, this will just be then X over sine 48 is equal to 17.091 blah 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 divided by sine 118. Yeah. Now to get X on its own, we're just going to multiply both sides by sine 48, aren't we? So the answer would be 17.091 blah 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 over sine 118 times by sine 48. So now we'll just put this into the calculator and see what it gives. Put this into the calculator. Remember now, I also have this stored. I don't have to write the 17.0 blah, blah, blah again because I have it stored. So it'll be answer and then sine 118 times by sine 48. And this gives me 14.385 blah, blah, blah. And they wanted it to how many decimal places? One decimal place. So that's just going to be 14.4, isn't it? Yeah, so the answer is just 14.4 and it's in meters, I think. Yeah, perfect. It's in meters. So the answer is 14.4. Anybody get this correct? Anybody get this correct? And for anybody that didn't get this correct, is this all clear? Does this make sense? Yeah, this is a 5-mark question. This is a 5-mark. This will be 5 marks in an exam. So if you can do something like this, then this is a really good question. Yeah? Cool. Cool. All right. So we've done that one. Let's continue. Let's do another one. We've got this one here. We got this one here. Let's see this one. Okay. So, sorry, let me get the marks as well. It's always a good thing. Okay. So it says sketch the graph of that one there. It's for 5 marks too. Sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intersection of the coordinate axes. So this is 5 marks. I'm going to give you about 5 minutes to try it, see how you get on, and yeah, we'll go for it together. In the meantime, I'm just going to go through the chat just to make sure we're all okay. Everybody's getting on okay with this one. So, or getting on okay with the questions so far. Also, as well, let me know how you're finding this as a question. Put a 0, this is very confusing. Put a 10 if you're finding it's very, very easy and very straightforward. If there's anybody that's completely confused, completely stuck, has no clue where to start, please let me know. So I'll give you guys about maybe a minute more, a minute and a half more. I assume that we're all okay. There's nobody that's completely stuck and that's doing nothing. We're all okay. We've all made a start. Last 30 seconds. Okay. It's been about 5 minutes. If anybody has an answer, just let me know in the chat. We're gonna go through it together now, though. So it says we need to sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercept with the coordinate axes. Okay, so the first thing for me, whenever I'm trying to sketch a graph, I need to know what type of graph it is. That will determine how the graph will look like. I should have a general idea of what the graph should look like before I even sketch it. That way I know whether I'm going in the right direction or not. Now, can somebody tell me, please, what type of graph do we call this? Or expression, I should say. What type of expression do we call this? So I'll give you guys a hint. I'm going to highlight this power here. Can somebody tell me what type of expression is this? Begins with a Q. Right, exactly. Thank you very much, Jane. Exactly. It's a quadratic for sure. Now, this is a quadratic. Put this here. So put this here. This is a quadratic. The general shape of a quadratic is just a U shape. That's if the x squared term is positive, and it's a upside down U or a frown, right? If it's negative, like this. Okay. So now, dealing with this, well, we know that the general shape must look like the first one. And we just need to, what I'm going to draw an axis like this here. And obviously the question says that we need to show the coordinates of the turning point, the exact coordinates of any intersection with the coordinate axes. Okay, so for me, straight away, the first thing that I would be able to spot is the y-intercept. Can somebody tell me what's the y-intercept of this graph? What is the y-intercept of this graph here? Exactly. Thank you very much, Ashira. It's just -5, isn't it? Because we just have a -5 at the end. The number at the end is always the y-intercept. So this is just a -5. Let me put a -5 here, for example. Let's just say it's like a 1 here. And then now, we need to figure out the turning point and any intersection of the coordinate axes. So right now, we know the y-intercept, right? The y-intercept, this is the y-intercept. We need the x-intercept, which we call roots, right? Now, there's a couple ways to do this. Now, what we're going to do first, though, you'll see why, is we're going to figure out what the turning point is. Yeah? Now, we're dealing with a quadratic here. Can somebody tell me, how do we find the turning point when we're dealing with a quadratic? Does anybody know how to do it? It's some algebraic process. Does anybody know the name? Yeah, exactly. It's completing the square. Exactly. Well done to me. Fantastic. We need to complete the square. If you ever have a quadratic and you need the turning point, you complete the square. Now, how do we complete the square with stuff like this? Well, we've got 2x squared minus 8x, and we've got -5. I take out a 2 first, x squared minus 4x, and then minus, if I take out a 2, I need to get back to the 5. I need to divide it by 2. Then this is going to be 2.5, isn't it? Yeah? And then now what you do is you complete the square with everything inside. Yeah. Now when you're doing the complete square, it's very straightforward. All you're doing is this. I've got this 2 here. Now you look at these two terms here. Now all you're going to do is you're going to put a bracket like this. You're going to put an x here. You're going to put a squared here. And then the number in front of the x term, which is in this case is a -4. You're just going to half it. That number is a -4. Half of -4 is a -2. And then all you're going to do is you're going to take away the square of that number. Yeah? This is a 2 here. You take away the square of this. The square of that is 4. So you're going to put a -4 here. And then, so basically, this part here, right, is exactly the same as this part here. These are exactly the same. The two things in yellow are exactly the same. Yeah? And then you're just going to attach on the -2.5 at the end. Yeah, so you get this. Does that make sense so far, guys? Should I make sure we're all okay with that? I've just completed the square. Is that clear? Okay. Cool. Cool. So now continuing now. Let me just rub this out a bit. Okay. Perfect. So now continue. We're just going to tidy this up. So it becomes x minus 2 all squared. And then -4 minus 2.5 is -6.5. So therefore, it will just be now I've got 2 lots of that. Now remember, whenever you're completing the square, you want to expand the bracket, right? Now, because this is 2 and then times this x minus 2 squared, you're just going to do 2 and then you're going to put an x squared like this. That, and then you're going to do this one here. 2 times -6.5 is going to be -13. So now the turning point of this here, all you do, whenever you're figuring out the turning point, is very, very easy. You're just going to do this here. You're going to look at the inside where the bracket is, and you're going to look at this number here. This is a -2. All you're going to do is just do the opposite. You're going to flip the sign. If it's -2 here, this will just be +2, +2. And this here stays the same. The number on the outside stays the same. Yeah, that's all you need to remember. So the turning point would be +2, -13. Does that make sense, guys? And did anybody get this correct? Did anybody get a turning point of -2, 13? Okay. If you didn't, no worries. Just let me know if it makes sense. But I'm not seeing any message in the chat, so I'm assuming it's all okay. So, well, roughly speaking, then, well, if -5 is here, -13 must be somewhere down here for sure. Let's just say 2 is, I don't know. Let's just say 2 is here, for example. The turning point would be like this, isn't it? This will be the turning point, and it will be like this: 2 -13. So now we've got two parts done. We've got the y-intercept, and we've got the turning point. Now we need to figure out what the x-intercepts are. Now, the x-intercepts of any graph, right? If you're along the x-axis here, the x-intercepts are just when y is equal to 0, right? So if we're looking for the y-intercepts here, right, we're just going to make y equal to 0 and solve. But to be honest, what you've done here, let me just write this out. We've got y is equal to 2x squared, and it was -8x minus 5. And then remember, we actually completed the square though, right? We completed the square, and we got it to this. Y is equal to, and then 2 bracket x minus 2 all squared minus 13. Yeah. Now, the reason why I'm showing you this is because you can actually use this one to help you find the roots very quickly. Because if I make this equal to 0 now, because that's what we need to do to find the x-intercept, we make y 0. If I replace this one with 0, it becomes 0 is equal to 2 lots of x minus 2 all squared, and then minus 13. And then now you're just going to move things around, aren't you, to get x. So therefore, if I move this over here, if I move the minus 13 over to the left, I'll get 13 is equal to 2 lots of x minus 2 all squared. And then I'm going to divide by 2. If I divide both sides by 2, I would get 13 over 2, or 6.5, is equal to x minus 2 all squared, right? And then now, what you want to do is, remember, you're trying to get x here. Whenever you're solving an equation in completed square format, you don't want to expand again. There's no point. You just take the square root of both sides. So it's just going to be the square root of 13 over 2 is equal to x minus 2. Now, remember, you've got to be very careful when you're square rooting. Now, quick question for you guys. Is the answer only the square root of 13 over 2? Or is there another answer? How many answers do you get when you square root a number? How many answers do we get when we square root a number? What do we think? Exactly. Thank you very much, Johnny. It's 2. You get a positive answer and you get a negative one. Whenever you square root a number, remember it's plus or minus for sure. Yeah. So we need to attach the plus or minus whenever we're square rooting, especially because you've got your calculator paper coming up now. This can easily come up. Remember, the calculator only gives you the positive one. So you need to remember that there's a negative one too. So now let's continue. Well, we know that x is equal to, so we know that the square root of 13 over 2 plus or minus equals x minus 2. And if I want x on its own, I will just add 2 to the left. So it'll be like this: 2 plus or minus the square root of 13 over 2. So that tells me that I get 2 answers for x. One answer for x is going to be 2 plus the square root of 13 over 2, whatever that is. And the other answer for x is 2 minus the square root of 13 over 2, whatever that is. Does that make sense, guys? Is that all clear? I just want to make sure all okay. I'm just going to wait for anybody just to say yes or no. We're nearly done with this question. We're pretty much nearly done. I just want to make sure all okay just before I continue. Anybody have any questions? If I don't see any messages in the chat, I'll just assume that we're all okay with it and I'll continue. Okay, cool. So then, remember, the question asks us to figure out the intercepts. We now know them. The 2 intercepts are at x equals 2 plus the square root of 13 over 2 and x equals 2 minus the square root of 13 over 2. Yeah? So putting this here. So the part we are doing, what we finding, yeah. So the part we're doing, we are finding the parts of the graph which crosses through the x-axis. Because remember, we set y equal to 0. The x-intercept is y is equal to 0. Remember, on our graph, that is along this line. So what we've figured out now are the two values of x for where it goes through. Because remember, the quadratic is a U shape, isn't it? So it's going to be a smiley shape, right? It's going to be a smiley shape. Where's my pen? Which goes like this. It has to go through, let me just do this a bit better. Has to go through like this here. Like that. So it basically looks like this. And then we've got these two values of x, which we now have here. Yeah? So putting this here, we just copy this here, put this here. Well, these are the two values of x. Yeah? So clearly, can somebody tell me then, which one would go here? Would it be the plus version or the minus version? Which one would go on this one on the right? Exactly. Thank you very much, Ashay. It'll be the plus one. Thank you very much, Jane. It'll be the plus one for sure. And what you can do just to be on the safe side, you could always just double check with your calculator for sure, right? Because this is the bigger one. And then this is the smaller one. So it has to be like this. Yeah. So it's definitely like this. But what you can do just to be on the safe side, this is our final answer, but just be on the safe side. Is 2 minus the square root of 13 over 2, is that actually a negative number? Let's check. 2 minus the square root of 13 over 2. Whoops, 13 over 2. This is equal to 4 minus 26 root 2. That is negative. Perfect. And then when we do this one here, plus 2, obviously it's positive, clearly, but yeah. So can you see now you're fully convinced this is the correct answer? Because remember, the answer is to sketch this graph. We've sketched it. We've shown the turning point at the bottom, the y-intercept -5, and the two values of x that it goes through on the x-axis. That is our answer. Is that clear, guys? Is that clear? Anybody have any questions on that? How do we feel about this if this was to come up? Put a 0 if you're thinking this is very still difficult, and put a 10 if this comes up, I'll definitely get the full marks. This is a nice full 5 marks to get. What do we think? Yeah? Okay. Cool. Cool. So we've done that one, 6 or 7. Good stuff. All right. So we've done that one. Let's do a couple more. Let's do this one here. Let's do this one. See how we get on. Okay. So we got this here. Got this here. Okay. Have a go at this one. See how you get on with it. And we'll go through it together. It's 4 marks. I'll give you about 4 minutes to try it, and then we'll go through it together. So having a look at this one, guys. What are our thoughts on it? Put a 0 if you're looking at this thinking, don't know what to do, very confused, don't like bearings, especially when it's like this. Or put a 10 if this is super easy, I know exactly what to do. Okay. You can see a 0 in the chat. So I'm gonna talk for anybody that's still working through it, just continue. For anybody that's a bit stuck or confused, have a listen. So it says a ship sails from P to Q, then from Q to R. Q is 12 miles from P on a bearing of 80 degrees. R is 28 miles from Q on a bearing of 155 degrees. It says, work out the directed distance from P to R. Okay. Well, what I would do, even if I don't know what's going on here, well, where is P to R? That's just that line on the bottom. Now, if I draw a line from P to R, like this, whoops, like this here, all of a sudden, I have a triangle, don't I? Now I've got a triangle that I've created because Peter R makes the final side of the triangle. And what do I have here? Well, I have distances. I've got angles. What topic is this? For anybody this is especially, this is for everyone, but especially for those of us that put a 0 in the chat. What topic do you think this is? We did it earlier today. It must be trig. Surely. This is a trig question. Exactly. Exactly. Thank you very much, Johnny. It's a trig question, right? Because we've got triangles and we've got angles and so on and so forth. The question is asked us to work out the direct distance of Peter R. So we're looking for this distance here, for this distance right here. Yeah. So how do we do that? Okay, well, because I've got a triangle here, maybe I would have a look at the diagram, see if I can figure out any angles, etc., and then try and calculate it. So that's your hint. I'll give you a few more minutes and then we'll go through it together. But for those of us that put a 0 in the chat, is this clear? Does that make sense? I want to make sure we're all okay with that. Yeah, good stuff, good stuff, good stuff. So yeah, give you about 2 more minutes and we'll go through it together. Okay, okay. So it's been a couple of minutes. So let's go through this together and see. So it says a ship sails from P to Q and then from Q to R. Q is 12 miles from P on a bearing of 80 degrees. R is 28 miles from Q on a bearing of 155. We need to work out the direct distance. So as I said before, we now have a triangle due to the fact that we are calculating distance from P to R. Now, it's clearly a trick question. So for me, I would also maybe try and figure out if there's any angles that I could maybe calculate inside the triangle. Now, the first thing I can see, remember when you're dealing with bearing questions, right? You always have a set of parallel lines. Now, we could use our parallel lines rules to figure out this angle here. Now, this side here, right, and this side are connected somehow. They are called co-interior angles. Does anybody know what this angle would be based on co-interior angles? Can somebody tell me in the chat? Exactly. It'll just be 100, isn't it? Right? Because opposite angles in co-interior, they must add to 180. So if that's 80, this one must be 100. Now, all of a sudden, I've got a point here, and I've got this missing angle, which I can now calculate because angles about a point make 360. So this angle Q here, this angle Q is just going to be 360 minus 180 minus 155. Yeah? So therefore, if I get my calculator, be 360 minus 180 minus 155. This is equal to 25 degrees, isn't it? Yeah? This is equal to 25 degrees. So if that's 25 degrees, And I'm looking for, let me just do this a bit more so it's a bit clear. This is 25 degrees here. And I'm looking for the opposite side. Well, I have two sides and an angle in between. I can apply the cosine rule again, can't I? Because it's exactly like one of the questions we did earlier in the lesson. We've got two sides and an angle in between. We can call this, if I call this q, lowercase q, then it's just going to be q squared is equal to those two sides, 12 squared plus 28 squared, minus two lots of those same two sides, 12 and 28, and then we multiply by the cosine of 25. Now, before I continue, is that okay, guys? Is that clear? Just want to make sure we're all okay with this just before I continue. I'm just going to wait for anybody just to say yes or no, so I know that this is all clear, especially for those of us that were a bit stuck on it. Is this clear? Okay, good, good, good. So, okay, I can see a no actually. So all I've done here, so let me just get the formula again. Just get the formula again. So all I've done here is I've used this formula. So remember we did this earlier in the lesson. We're looking for a side, right? We're looking for a side. The cosine rule states that, I'll just get this part here. This part here. Let me delete this part and I'll delete this here. The cosine rule can be used to work out a missing sides or angles in triangles. The sides formula is this. This version of the cosine rule is used to find the missing side if you know two sides and the angle in between. So basically what this is that you have a triangle like this here, and then you have, let's say this is capital A. Let's say this is A and this is, sorry, that won't be A. Let's say this is B and this is C, and this is always lowercase a. Then can you see from the formula, we've got these two sides, B and C, B and C. We have this cosine of A, the angle in between. All I've done is just apply that formula. Does that make sense now? Can you make sure we're all okay with that? Yeah? Good, good, good. So now continuing, we're pretty much home and dry because we can just plug this into the calculator. Yeah? So putting this here, let me get my calculator out. I'm just going to be, move this here. It's just going to be 12 squared plus 28 squared, minus two lots of 12 and then 28, and then cosine of 25. This here, 12 squared plus 28 squared minus 2, perfect, perfect. And then I get this here, 318.961, blah, blah, blah. So therefore Q is just equal to the square root of that, isn't it? Right? Now remember, because I've stored in my calculator, I don't need to write it out again. I can just do the square root of answer. So therefore it'll be the square root of answer, which is just equal to 17.859, and they didn't say any degree of accuracy, so I'll just give it to three significant figures, so 17.9 miles. Is that clear, guys? To make sure we're all okay with this. Okay. Oops, I just realized something as well. I just realized something. I actually used the wrong angle here, to be fair. I just realized this here. I put 100 here, 155. This should be 100. I just realized that now. 100, that should be 100. So that will change the angle. And it will just be like, let me just tweak that again. So let me just do 360 minus 100, minus 100, minus 155. 155, that should give you 105. To be fair, I did think the angle was a bit small. But yeah, so that is, I've done the wrong angle here. So let me just tweak this again, 105 here. And that should be 105 like this, 105 here. Yeah? So I just put the wrong number down. So that should be 105, and then that will give me something different. So let's just do this here very quickly then, just to finish off. So it'd be 12 squared plus 28 squared minus two lots of 12 and then 28, and then cosine of 105. Yeah, just make sure 12 blah blah. Yeah, that's fine. This is going to be that there. Let me just make sure that's okay. 12 squared, 12 minus, yeah, that's all fine to me. So that should be like this. This here basically. So 1101.926, blah, blah, blah. So if I take the square root of that, this would give me 33.195, and that is the correct answer. So it'd be 33.2. Yeah, perfect. 33.2 miles. Sorry about that. Does that make sense though? Did anybody get this correct? So just be, as you can see, even with me, sometimes you're writing something down, you use the wrong value. Yeah? Yeah? Good stuff. Good stuff. Cool. Cool. How are we feeling about next Wednesday? Confident? Happy? Happy to finish? Nervous? What are our thoughts? A little bit nervous, scared, but happy. Don't worry, guys. You guys have been doing so well. You've done 2 exams so far, and you've got one more. Is that your last exam overall, or have you guys got still a bit more after Wednesday? Okay, okay, maybe a couple of physics and then music. Fair enough. Physics is my last exam. Still more. Don't worry. But it's your last week, right? For sure. Definitely your last week for sure, right? Yeah, good stuff. Good stuff. Okay. So yeah, just to let you guys know as well, I'm going to be uploading this lesson into YouTube. So if you ever want to watch it again, you're more than welcome to. This is my YouTube channel. I've got another lesson after, so I will upload it after I finish. So it'll probably be up on YouTube at about 6 o'clock today. So if you want to watch it again, you're more than welcome to. I did another one last week. So if you want to watch that higher paper, it's there. You can watch it. My YouTube channel is just Maths with Dan. I'll put it in the chat just in case anybody wants to subscribe. And yeah, so I hope you found that beneficial today. So just put it in the chat. And also as well, I'm also on a TikTok as well. So if you want to follow me on TikTok, you can. I'm just going to be uploading more videos, and I'm also on Instagram and Twitter too. Yeah. So we'll leave it there today. I hope you found that beneficial. Hope you guys are going to enjoy the weather wherever you are. Good luck for Wednesday. You're going to smash it. You're going to do absolutely amazing. And yeah, please keep in contact and let me know how it goes. Yeah. Take care, guys.